Hello students, welcome to my YouTube channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of series on online electronics laboratory, and in this part we'll discuss lab exercises on transistors. The assignments here includes the common base transistor, common emitter transistor, JFET and MOSFET characteristics. Coming to the last assignment, that is assignment 4, that is MOSFET transistor characteristics. In MOSFET, we are using enhancement type MOSFET here. So, we have to connect the circuit as shown. We connect DC supply to gate side as well as the drain side, and we will observe the drain current and drain to source voltage. First of all, we will keep VGS 0 and we will vary the drain to source voltage and we will observe the current flowing through the circuit, that is the drain current. Now, we will keep VDS constant and we will vary VGS and we will observe the drain current for different values of VGS. Now, we will do the MOSFET practical, which is enhancement type MOSFET, as you can see the symbol here. So, there is no channel which is connecting drain and source voltage. Again, this is the gate voltage which is kept to 0 value, and this is the drain voltage which will increment, and we will see the drain current. As we go on incrementing the drain voltage, there is no drain current flowing through the circuit. And the simple reason behind this is there is no channel for the current to flow. There is no channel for charge carriers to move from source to drain region. Now, we have to apply gate voltage so that we can observe the drain current. So, we are increasing the gate voltage. We have increased it to 2.1 and there is no change in the drain current. So, we have to increase it further, and now the drain current starts flowing. For change in the gate to source voltage, we have fixed it to 2.6 volts. At 2.6 volts, drain current has started, that is, the channel has been created. Now, you increment the VGS value, the drain current is increasing. Now, you increase the VDS value, the drain current is not increasing because it is the pinch off value. Now, increase it from 0 to, will increment now VDS from 0 to 1 volts, and you can observe, see, it is 0, the gate voltage is 2.7. Now, VDS, when we increase it from 0, you can observe that the drain current is increasing 0.2, 0.4, 0.6 volts, and drain current has stopped incrementing because again it has reached to its saturation value, that is, now the transistor is working in active region. If we apply AC input, it will amplify it. In this experiment, the MOSFET which is used is enhancement type MOSFET, which means there is no channel for current to flow from source to drain. So, when we keep VGS 0, the drain current is 0. When we increase the VGS, it results in enhancement of the channel or creation of the channel, and current starts flowing through the circuit. We have observed the pinch off which occurs at lower values of the drain current as VGS increases. We have observed in this experiment that unless until a channel is created between source and drain, the drain current is 0. So, a threshold value of VGS is required to create the channel and for the drain current to start flowing through the circuit. I hope you have understood how enhancement MOSFET works. Thank you.